Hi, good day everyone. So today we're going to be discussing about hypothesis testing on two independent means. So by the way, I am Eunice S. Balonga, your lecturer for today. Hypothesis testing on two independent means. So this particular lesson presents a method for using sample data from two independent samples to test hypotheses made about two population means and to know if is there any significant difference between two population means, and it is used when comparing means from two different groups. For example, comparing two sections A and B scores on exams, or comparing two genders, male and female scores on a quiz, something like that. Two samples are independent if the sample values selected from one population are not related to or somehow paired or matched with the sample values. So here is the formula and the terms that we need to take note and to familiarize with so that we will be having an easy navigation and computation with regards to hypothesis testing with two independent means. The equation above is the formula that we're going to use, where x bar sub 1 is the mean of group 1 and x bar sub 2 is the mean of group 2. SS sub 1 is the sum of squares of group 1 and SS sub 2 is the sum of squares of group 2. N sub 1 is the number of observations of group 1 and N sub 2 is the number of observations for group 2. So that are the things that we need to familiarize. Now let's take a look at one example. So here's the problem statement. An English teacher wants to compare the spelling competency of the male and female students. He randomly selected 10 male students and 10 female students. At the significance level of 0.05, the English teacher wants to know if is there a significant difference between the scores of male and female students in spelling. So this is a problem statement that we're going to be solving for. So here are the spelling scores from the two independent groups, the male and female. Now the first step is defining the null and alternative hypothesis. So let's have the null hypothesis first. So the null hypothesis is saying that there is no significant difference between the scores of male and female in spelling. So if we're going to put it in a mathematical equation, so it will be x bar sub 1 is equal to x bar sub 2. Now let's move on to alternative hypothesis. So if the null hypothesis is saying that there is no significant difference, the alternative hypothesis is saying that there is a significant difference between the scores of male and female in spelling. So in a mathematical equation, that would be x bar sub 1 is not equal to x bar sub 2. And remember that it could also be greater than or less than as long as it's not equal. But in here, we just choose the not equal to sign. So here is the mathematical equations and also its substitution. So here are the means of the x bar sub 1 and x bar sub 2. So the mean of the group 1 or the male is 13.1 and the mean of the x bar sub 2 is 7.8. So I'm going to show you the solution later. The second step is identifying the significance level or the alpha level, which has already been stated in the problem statement, which is 0.05 or 5%. The step 3 is calculating the degrees of freedom. So this particular formula is for degrees for freedom for independent sample t-test. So df is equal to n sub 1 minus 1 plus n sub 2 minus 1. So for group number 1 or the male group, we have 10 sample size, and also the group 2, which is the female, we also have 10 sample size. So that will be 10 minus 1 plus 10 minus 1. That will give us 9 plus 9, and the degrees for freedom is equal to 18. Now let's take a look at the t-tabular values. So we have in the upper part the significance level. So we're going to choose 5% or 0.05, and then on the left side we have the degrees of freedom, which is of course 18 based on our calculation earlier. If we're going to connect that, we're going to get the t-tabular value of 2.101. So now we're going to state the decision rule. So we have here a representation of a curve in which the level of significance is 5% and is cut into two sides since we are applying two-tailed test. So in both sides there is 2.5%. And the t-tabular value, which is positive negative 2.101. And these will serve us as the area of rejection. So the decision rule is if the t computed value is greater than 2.101 or less than negative 2.101, we're going to reject the null hypothesis. Now let's proceed to the calculation of the scores, which I bet you already have known how to do this. So we're going to create four columns. In column number one, we have the male or the X sub 1 or the group 1. And then after that, we're going to add all of their scores, and that will lead to us a summation of X sub 1, which totals to 131. Then, as you can see, there is N sub 1 below that summation of the X sub 1, and that pertains to the sample size of the group 1, which is 10. And then the mean of the sub 1 or the group 1 is 13.1. That is calculated by dividing the summation of x sub 1 all over the sample size, which is 10. That will going to give us x bar sub 1 or the mean of group 1, which is 13.1. Then let's have the column 2, which is x squared sub 1. So in here we're just basically going to square the scores from x sub 1. So for example, in 14 squared is 196, and then below that 18 squared is 324, and so on, and that will give us the summation of x squared sub 1 that equals to 1891. Looking to the column number 3, which pertains to the second group, which is the female x sub 2, and then the same with the process of the male or the x sub 1, we're just going to add all of the scores of the females, and that will lead us to the summation of x sub 2 that equals to 78, and then the n sub 1 or the sample size, which is 10, and then the x bar sub 2, which is 7.8, that is computed from the summation of x sub 2 all over the sample size 10, which gives us the mean of group 2, which is 7.8. Looking to the column 4, this is done by squaring the x sub 2. So that is to say x squared sub 2. So for example, 12 squared equals 144, then 9 squared equals 81, and so on and so forth. At the end, we're going to arrive at a certain summation of x squared sub 2, which equals to 738. So now I'm going to show you the computation of the SS sub 1 or the sum of squares of group 1 and the sum of squares of group 2. If you want to go back, you can go back and check that the summation of x squared sub 1 is 1891, and then minus the summation of x sub 1, which is 131, and we're going to put it in the open and close parentheses because we're going to square it later. So all over the sample size, which is 10. Computing it, we're going to get the sum of squares sub 1 equals to 174.9. Now let's proceed to the SS sub 2 or the sum of squares of the group 2, which equals to the summation of x squared sub 2 minus the value of the summation of x sub 2 squared all over n sub 2. So we're going to get the summation of x squared sub 2 first, and in the table it is 738, and we're going to minus it with 78, and we're going to square it all over the sample size 10. Computing all of it, we're going to have the SS sub 2, the sum of squares of group 2, which equals to 129.6. So since we already have the values of the sum of squares of 1 and the sum of squares of group 2, then we're going to proceed to calculating the test hypothesis, which is step 5. So t is equal to x bar sub 1, or the mean of group 1, and minus the mean of group 2, or x bar sub 2, all over s sub 1 plus s sub 2 over n sub 1 plus n sub 2 minus 2 times 1 over n sub 1 plus 1 over n sub 2 square rooted. So what we're going to do is to substitute all of the things that we have computed earlier. So x bar sub 1, or the mean of group 1, is 13.1 minus the mean of group 2, which is 7.8. Then over the square root of 174.9, which is the sum of squares of group 1, plus the sum of squares of group 2, which is 129.6, all over n sub 1 plus n sub 2 minus 2. That will give us 10 plus 10 minus 2 times 1 over 10 plus 1 over 10, which below is the computed value of the difference between x bar sub 1 minus x bar sub 2, which is 5.3 over 304.5 over 18 times zero point 0.1 plus zero point 0.1 square rooted. If we're going to compute that in a scientific calculator, that will give us the square root of 3.384. So 5.3 all over the square root of 3.384 is equal to 2.88. Now let's proceed to step 6, which is stating the results. So what is the decision rule again? So our decision rule earlier says that if the t computed value is greater than 2.101 or less than negative 2.101, we're going to reject the null hypothesis. Based on our calculation, the t computed value is 2.88. So the result is, since the t computed value is 2.88 is greater than 2.101, we are going to reject the null hypothesis. It is because 2.88 is inside the rejection area, which is the positive 2.101. So we're going to reject the null hypothesis and accept the research hypothesis, or the alternative hypothesis. So now we're going to have the last step, which is stating the conclusion. So we're going to state the conclusion based on the context of the problem statement. So here it is. There is a significant difference between the male and female scores in spelling. So what does it imply? It implies that the male performs better than the female students, considering that the mean or average score of the male students is 13.1, which is greater compared to the average score of female students, which is only 7.8. So that's it for today. Thank you for listening. I hope you've learned something.